Hello, and welcome to another edition of AppSec Decoded, where we talk about building trust into software. I'm Taylor Armerding, security advocate with the Synopsys Software Integrity Group, and I'm joined today by two of our experts, Sammy Migues and Tim Mackey, to talk about some of the major trends we've seen in cybersecurity this year. Sammy is principal scientist with Synopsys and has been a co-author of the Building Security in Maturity Model report, better known as BSIMM, since it began in 2008. The latest BSIMM 12 was released in September. Tim is principal security strategist within the Synopsys Cybersecurity Research Center, which also has its own acronym, CyRC. He has a wide range of software security expertise, but his primary focus is open source software, which makes up the large majority of every code base developed in recent years. Welcome, gentlemen, and thanks for being here. It seems pretty clear that given the exponential increase in the speed and complexity of software development, that it is difficult to impossible to build security and compliance into software with manual processes. Humans can't keep up, right? So, Tim, starting with you again here, what shifts in processes have we seen companies implement to help them achieve effective CI/CD pipelines in a DevOps culture?
So one of the first things that we need to recognize is that from a build perspective, from a security perspective, you need to know exactly what you got, what your artifacts look like, okay. Why they were created, who created them, and what role they're supposed to play. None of that can happen if you have the build machine being underneath some architect's desk and he kicks his power button turns on and away goes the build and out pops something, and when he's done he turns it off because the thing is really, really hot because it's been around for 10 years. Trust me, I've been there. It doesn't work very well. The modern view is I run everything in containers. I now have a containerized build system so that I use the lifespan of how a container works to go and say, I start a build from a fresh known starting point. I go and I create all my artifacts, whether they be end result or something that's intermediary, and I create that artifact. I perform a series of tests on it. Those tests get the thumbs up. I store it someplace. And if those tests don't get the thumbs up, I save off the logs so somebody can go figure out what went wrong, but I destroy that thing so that nobody can come back and go and take the broken stuff and put it into a production environment. That's one of the big changes that's happened over the last, say, 3-4 years that is going to increase the overall security of what people deliver.
Mm-hmm. Sammy, anything else to add to that?
Yeah, sure. So when we talk about shifts in processes to achieve effective CI/CD, I think we're talking about a couple of other things too. That again, I hate to harp on the top-down view because the bottom-up view is so important as well. But from a top-down view, you know, we've seen shifts in the acceptability of digital transformation. So governance is code, policy is code. The shift in the willingness to put some of these policy decisions into bots and embed them directly into CI/CD pipelines. We've seen shifts in processes away from big centralized security gates to much smaller decision points and guardrails. We've seen shifts away from I'm going to pen test at a gate just before I go to production to I'm going to do as much testing as I can before then, but I'm going to do the rest of the testing after that. And I'm going to go to production with a little bit of unknown risk, and then I'll handle it through A/B testing, through rollback mechanisms, or through whatever. Automate first, shifts in processes to help implement effective CI/CD. Automate first, otherwise you're never going to get effective CI/CD. Otherwise you just have people waiting on processes, or you have processes waiting on people. So there's probably, that was 5, there's probably a dozen of these kinds of things that without which we wouldn't have been able to get as far as we have right now in terms of automation. But again, I would say that our ability to automate, our ability to know how to make it work, I can make it work, versus I know how to make it work securely. Our ability to automate has far outstripped our ability to know how to make it work securely, even if it's even possible with all the things that are interacting today, you know, in CI/CD pipelines, build servers, clouds, patch servers, everything else, if it's even possible to make it operate securely.
That's interesting, and I think it sort of leads into this next question, which is how are organizations effectively making use of their existing AppSec tools in their new CI/CD pipelines? I mean, it sounds like maybe not so much.
Well, for me, it's a slice of all of those things, right? So we used to have big monolithic AppSec tools, whether it was SAST or DAST or IAST or something. And, you know, we rolled it over a la Flintstones to where it was going to work. And then when we got there, we smashed into it and it worked for a little while and everybody waited and they went, oh, and it spit out some answers and we did some stuff. I would say the vast majority of the first step towards improving that was we just started calling the tool with a CLI, with a command line interface, you know, like automation, yay! We're all taking the rest of the year off. We're going to Disneyland. So we said, hey, look, I can just call this from this script and it'll give me some answers. Now, does it work as well as when a human ran it with all the configuration items, with all the code fit in, with the tool in the code, you know, smashed together a la static analysis or whatever? You know, no, probably not. But did it work? Sure. You know, and then did we turn off some rules to make it work faster? Or did we run it 5 times with different sets of rules so that it ran, you know, 15 minutes, 15 minutes, 15 minutes, 15 minutes instead of 2 hours? Sure. So, you know, when we talk about how are we managing our humongous investment in legacy security tools, so then we have to, so we don't have to take all that technical debt, all that technical escrow, and just toss it out the window and go buy new tools. We're figuring out how to run the tools a little more programmatically. We're figuring out how to decompose the tools to the extent possible to run them in pieces. We're figuring out how to run them overnight. We're figuring out how to apply some basic, if then else, kind of machine learning to maybe triaging some of the results. We're learning how to make some policy that says if it looks like a duck, walk like a duck. I got no time for ducks. So we're not going to worry about that. We're going to put it below our risk management threshold. So it's forcing governance kinds of decisions. So I think there's a handful of things that organizations are doing. Now you had a word in there, and then I'll stop rambling. You said, how are they effectively making use of their existing AppSec tools?
Correct.
I don't know that they're effectively making use of their existing AppSec tools so much as protecting their legacy investment, which numbers in the billions at this point. So nobody can afford to throw all that stuff away. So how do we ramp down these huge monolithic tools that are hard to run, frictionful, and everything else, while we ramp up, you know, our ability to do things in talk time, if you're a DevOps person, in a real CI/CD way, in a real DevOps culture. And this is a really hard question. And quite frankly, most of your governance folks are never going to solve this question. This is a real technical question that happens in the technical organization for the technical folks, but they can't decide what security we do. So what's really this balance between better, faster, cheaper, but I still have all the governance I need without throwing away everything I have today before I can replace it with something new? This is a hard question, but lots of people have made lots of progress on this. It isn't that hard.
Thanks. Okay, Tim, how can companies make sense of all their application security testing data to effectively, there's that word again, effectively address business risk?
Well, I'm going to go out on a limb and I'm going to assume that few people have actually turned off their tools to get a 0 findings result, and that they still are dealing with lots and lots of findings.
Yeah.
And one of the best ways to look at this is not taking where do I start? You just arbitrarily pick a starting point, because for practical purposes, you want something that's more of a continuous improvement model. You don't want to be in the, I want perfection. I don't want the shiny diamond, because that shiny diamond may have a set of risks that are outside my control. I want to have an understanding about how that set of findings is going to be remediated. I've got my own custom code. Well, I can go to my developers and say, fix that. But something that's coming from, say, an open source library, I might not necessarily have the same mechanism to get it fixed. If I have a third-party API, there might be no way to get that fixed. So having a mechanism in place that starts to enable triage is really the right path forward. Something that allows for the world of continuous improvement to be your benefactor. So one of the canonical examples I have is, let's say that you're running a static analysis tool and it goes and says you've got 100 issues to go and remediate, 13 of which are related to something in the OWASP top 10, like SQL injection. Well, maybe I just go and decide that I'm going to have a sprint that takes care of SQL injection, and I'm just going to let everything else be something that is known. And oh, by the way, that 13 count for SQL injection, that's a fixed number. So if before I get to it, I suddenly start seeing the number decrease, I have to ask the question why. If I see the number increase, I need to look at the commits that cause the number to increase. So I start to look at it through the lens of how can I improve the system while maintaining the status quo for things that aren't effectively broken.
Okay.
Then you're in a position where you can actually start to take whatever you have for your investment today, however many billions of dollars that you've spent on AppSec tooling, and make the most of what you've got, all while kind of improving the current situation.
Sammy, you have anything to add to that? That's a great answer. I'll add something short. You can't make sense of it if you don't know what it is, how it's made, and what you're going to do with it. So we can talk about, you know, I bought a coin sorter. You know, I have all this AST data. I have penny size data, nickel size data, quarter size data, and so on. And I throw them all into this coin sorter, and it sorts them. And for a lot of organizations, they have now, to use your words, made sense of that data because it's all sorted, right? And then what do I do with the pennies? What do I do with the nickels? As Tim, you know, very correctly pointed out, maybe these pennies, these nickels, and these dimes are closely related, and they need to be solved horizontally. If you don't know what you're trying to accomplish with this data, well, I'm trying to lower risk. Okay, well, I'm trying to lose weight. Okay, well, there goes an arm. Look, I've lost 25 pounds. You know, well, that was probably the wrong answer. So unfortunately, for a lot of organizations, making sense of all this data means they have to have asked themselves intelligent questions that are actually answerable by analysis of the data. And questions like, am I more secure today than I was yesterday, is not an answerable question from security testing data. And so what are the questions I can answer? What is the analysis I can perform on what data? And how will I get to the point of realizing, because if you don't, you're still doing it wrong, that it's the trend in those answers that actually tells me what's going on, not each individual answer.